Hi guys, welcome back. What we're going to do today is look at some more examples of integration by substitution. We're going to look at a bunch of them. So we're going to go ahead and get started here. Okay, so our first example is the integral of 5x squared plus 1 squared times 10x dx. So again, we need to pick our u. And we're going to check this mentally to figure out which term should be our u. We're going to check this term in here and this term here. So let's check the first one first. If I were to derive 5x squared plus 1, what would I get? And the answer is 10x. Now that happens to fit perfectly with this term. So since I know that the derivative of the first term will give me all or part of the other term, this needs to be our u. Okay, so let's go ahead and get this started. So we're going to do u equals 5x squared plus 1. Okay, so we need to derive that, which gives us 10x dx. And now, if you choose, you can solve for dx here. So that means we're going to divide both sides by that 10x. So that's going to give me 1 over 10x du equals dx. And now we're going to go into our integral and re-substitute these terms in there. So integral, now the first term we substituted with u, so that's now going to be u squared. We still did not have anything initially to resubstitute 10x with, so we're going to leave that as is. So 10x. Now dx is going to be replaced with 1 over 10x du. And we're going to see if anything cancels or simplifies, and it always should, okay? If nothing gets canceled or simplified, you've got to go back and pick a different u. So the 10x's here will actually cancel, okay? And that's a really good thing. Now, when I multiply this u squared by this 1, nothing's going to change, so we don't have to worry about it. So our rewrite will look like this, u squared du. And now we integrate. So we add 1 to the 2, divide by that sum, which is 3. That means it's going to be 1/3 u to the third plus c. And the last step is to resubstitute. So 1/3 times 5x squared plus 1 cubed plus c. And that's it. All right, on to the next one. All right. So in this case, we have a quotient, okay? And we also have a radical in the denominator. My first recommendation when you get a form like this is actually to rewrite it first, okay? Without fractions. So the way we're going to do that is, first of all, I know that this square root sign down here is the same thing as x squared plus 1 to the 1/2 power, okay? So also what I know is that it's in the denominator. When I move a denominator up to the numerator, the exponent will change its sign. So it's going to go from being positive to negative. So when we rewrite it, it's going to have the x first from the numerator, and then in parentheses, we're going to have the denominator. So x squared plus 1 to the negative 1/2 power dx. So that's going to make this process a whole lot easier if you can rewrite these functions a little bit nicer. Okay? Now, again, we want to think of what our u should be. Let's check the first term. The derivative of x is just 1. Well, there's way more stuff in here than just a 1, okay? Not a good fix. Let's try the next one. The derivative of x squared plus 1 would be 2x. Now, that's good business because we may not have a 2, but we sure have this x that we need to take care of. So this is going to be our u. So let's go ahead and start. We've got u equals x squared, oh, there goes my pen again, plus 1, and then our du is 2x dx. Again, solve for dx. We're going to divide both sides by that 2x, so that's 1 over 2x du equals dx. And now we're going to substitute. So here we go. We're going to rewrite our integral. Now the x was not replaced with anything, so I'm just going to rewrite it. This is now u to the negative 1/2, and dx gets substituted with 1 over 2x du. Now, the good thing here is that we've got a pair of x's that are going to cancel, and that's the great thing about this. So we're going to cross those out, and we're going to rewrite. And of course, just like in the example I showed you in the first video, we're going to take this 1/2 and put it first. And since I know it's going to be written first, I'm actually going to put it on the outside of the integral because it is a coefficient. So I'm going to do 1/2 right here, and then I'm going to rewrite everything that's inside. So we have u to the negative 1/2 du. And now we integrate. So we're going to add 1 here and divide by that sum. Negative 1/2 plus 1 is positive 1/2. So that's going to be 1/2 times, now when you divide by 1/2, it's the same thing as multiplying by the reciprocal of 1/2, in other words 2. So the dividing by 1/2 is just going to become a 2. And then u to the positive 1/2, that's a positive square root, mind you, plus c. All right, we're going to clean this up. Now the 1/2 and the 2 are going to cancel. And then I'm going to resubstitute u with what it was originally. That was x squared plus 1 to the 1/2 power plus c. Now you could also rewrite that power of 1/2 as a square root, okay? So just in case, depending on how you are comfortable rewriting this, we can also do this like so. So we could do x squared plus 1 under a radical plus c. Either of those answers would be perfectly acceptable. All right, next one. We've got the integral of 1 plus 2x to the 4th times 2. And just keep in mind at any point in this video, if you want to test yourself, please pause the video and see how far you can get with these on your own. That's going to be incredibly helpful for you later on. So again, we need to check what's going to be our u. Okay, now let's take a look at the first term. The derivative of 1 plus 2x is 2. That is sitting right here. This is going to be our u. So u equals 1 plus 2x du would be 2 dx. Solve for dx, that would be 1/2 du equals dx, and now we substitute. So we're going to rewrite our integral. The 1 plus 2x is u, so u to the 4th. There we go. I have not done anything with this 2 just yet. The dx is now 1/2 du. Nope, come on, pen. There we go. So, good thing, we've got some things that are canceling. The 2 and the 1/2 are now gone. So, we're going to rewrite one more time. We've got u to the 4th du. So, we look like we're ready to, and set to go here. So, we're going to integrate. We're going to add 1, divide by that sum. So, I have 1/5 times u to the 5th power plus c. Last but not least, we integrate. Or I'm sorry, we're not going to integrate again. We're going to substitute u, which is 1 plus 2x. And there you go. So stick around for part 3 for more examples of integration by substitution. Thanks for watching.